Zooplankton are heterotrophic, sometimes detritivorous, plankton. Plankton are organisms drifting in oceans, seas, and bodies of fresh water. The word zooplankton is derived from the Greek zoon, comma meaning animal, and planktos, comma meaning wanderer or drifter. Individual zooplankton are usually microscopic, but some, such as jellyfish, are larger and visible with the naked eye. Ecology: zooplankton is a categorization spanning a range of organism sizes including small protozoans and large metazoans. It includes holoplanktonic organisms whose complete life cycle lies within the plankton, as well as meraplanktonic organisms that spend part of their lives in the plankton before graduating to either the nekton or a sessile, benthic existence. Although zooplankton are primarily transported by ambient water currents, many have locomotion, used to avoid predators, as in vertical migration, or to increase prey encounter rate. Ecologically important protozoan zooplankton groups include the foraminiferans, radiolarians and dinoflagellates. The last of these are often mixotrophic. Important metazoan zooplankton include cnidarians such as jellyfish and the Portuguese man-o'-war, crustaceans such as copepods, ostracids, isopods, amphipods, mysids and krill, chaetognaths, arrowworms, mollusks such as pteropods, and chordates such as salps and juvenile fish. This wide phylogenetic range includes a similarly wide range in feeding behavior, filter feeding, predation and symbiosis with autotrophic phytoplankton as seen in corals. Zooplankton feed on bacterioplankton, phytoplankton, other zooplankton, sometimes cannibalistically, detritus, or marine snow, and even nektonic organisms. As a result, zooplankton are primarily found in surface waters where food resources, phytoplankton or other zooplankton, are abundant. Just as any species can be limited within a geographical region, so is zooplankton. However, species of zooplankton are not dispersed uniformly or randomly within a region of the ocean. As with phytoplankton, patches of zooplankton species exist throughout the ocean. Though few physical barriers exist above the mesopelagic, specific species of zooplankton are strictly restricted by salinity and temperature gradients, while other species can withstand wide temperature and salinity gradients. Zooplankton patchiness can also be influenced by biological factors, as well as other physical factors. Biological factors include breeding, predation, concentration of phytoplankton, and vertical migration. The physical factor that influences zooplankton distribution the most is mixing of the water column, upwelling and downwelling along the coast and in the open ocean, that affects nutrient availability and, in turn, phytoplankton production. Through their consumption and processing of phytoplankton and other food sources, zooplankton play a role in aquatic food webs, as a resource for consumers on higher trophic levels, including fish, and as a conduit for packaging the organic material in the biological pump. Since they are typically small, zooplankton can respond rapidly to increases in phytoplankton abundance, for instance, during the spring bloom. Zooplankton can also act as a disease reservoir. Crustacean zooplankton have been found to house the bacterium Vibrio cholerae, which causes cholera, by allowing the cholera vibrios to attach to their chitinous exoskeletons. This symbiotic relationship enhances the bacterium's ability to survive in an aquatic environment, as the exoskeleton provides the bacterium with carbon and nitrogen.